Hello, we're going to do dividing radical expressions. I'm going to go through all the levels of IXL, so you'll be ready to do it. You can follow along with a pencil and a paper. So our problem here is, as we mentioned before, we can have radicals on the denominator. Now for other problems, if I write, for instance, 2 over the square root of 3, we had practiced before that in order for us to get rid of this square root of 3 on the denominator, we don't like that square root of 3. We're going to multiply it by the square root of 3 again. And when I do that, what is square root of 3 times square root of 3? What is a square root times itself? Well, square root of 3 and a square root of 3 become really a square root of 9, which is just 3. So essentially, when we multiply a square root by itself, the square root goes away and we're left with that inside number. Now, in order to make this fair, we need to multiply the square root not only to the bottom, but to the top, right? Because really this is being multiplied by 1. So we're not changing its value, we're changing the way it looks. And that happens all the time when we're practicing moving stuff across the equation. But in this case, when we practiced previously, when it comes to radicals as fractions, we multiply the same thing to the bottom and the top. Now this becomes 2 square root of 3 on top, because stuff on the outside stays on the outside, stuff on the inside stays on the inside, over the square root of 3 times square root of 3, you said was just 9, square root of 9, which is just 3. And we're done. Okay. Now, if you look at the problem on our left, this is a little different. Negative 9 over 5 plus square root of 3. Now, if I try that same trick, if I say, you know what, I don't like the square root, and multiply both sides by a square root of 3, top and bottom, what happens is the square root of 3 must multiply the binomial, both terms. And that becomes 5 square root of 3 plus the square root of 9, which is 5 square root of 3 plus 3. Now, if I rewrite this, negative 9 square root of 3 over 5 square root of 3 plus 3, do we still have a square root on the denominator? We do, right? So this move, though it worked back here, it seemed okay, it doesn't work when you have too many terms on the denominator. In this case, there's 2 terms. So we have a special rule this time, and it's called multiplying by the conjugate. Now let's do this problem over again. So this is not the way we do things, because we do not want a square root on the bottom. So let's write this problem again. Negative 9 over 5 plus square root of 3. The trick here is to multiply by the conjugate. By the conjugate. Okay, we're going to multiply by the conjugate. And what that conjugate means, we're going to take our term 5 plus square root of 3, and we're going to change it to 5 minus square root of 3, the top and bottom. Okay, multiply it to the top and bottom. Now, we're going to write that all out on the side over here, and we'll see what happens. Now, if you remember before, if I say x plus 2 times x minus 2, because it's a plus and a minus, our 2x and a minus 2x are middle terms, they will always cancel out. They will always subtract out, leaving me just x squared minus 4. Again, x times x is x squared, x times 2 is negative 2x, 2x, and then negative 4. So if you multiply it out, we end up with those 4 terms, and the plus minus term always end up dividing out. That's actually what we're going to do here, except our middle term is going to be, let's rewrite it, 5 plus square root of 3 times 5 minus square root of 3. Now, let's take our time. 5 times 5 is 25. 5 times square root of 3, this is negative 5 square root of 3. We're down the front. Let's do the back. Square root of 3 and a negative square root of 3 times 5 and square root of 3 times negative square root of 3. This becomes a plus 5 square root of 3, and a negative square root of 9. So we're left with 25. These terms in the middle, plus and minus, since exactly the same plus minus, they cancel each other out. And we're left with a square root of 9. The square root of 9 is really a 3. And that's just actually 22. So bringing this back up to the top, the denominator becomes just the 22. And the top, we can multiply that out by multiplying negative 9. By multiplying negative 9. By multiplying negative 9 times 5, and then negative 9 times square root of 3. Let's go ahead and finish that up. So it'll be negative 45, because negative 9 times 5 is negative 45, and negative times negative square root of 3 is positive 9 square root of 3, all divided by, we said the denominator became 22 after we did the problem. So let's go ahead and type that in. It's going to be negative 45. Oh, we need parentheses when you write this in. Or in this case, let's try the fraction mark. Negative 45 plus 9 square root of 3 on the denominator. It's just 22. Oh no, where did I mess up? Oh, I was correct, except if you look here, instead of putting a minus sign, I accidentally pushed an equal sign. But that's pretty much what we got. Got it. Okay, the second problem is very similar to that. We'll do another example here. So we have a negative 2 over 7 plus square root of 6. If I multiply just by square root of 6, the square root of 6 would still be on the denominator. So we have to multiply by the conjugate. And the conjugate is not 7 plus square root of 6, it's 7 minus square root of 6 to the bottom and the top. We multiply it out, take your time, 7 plus square root of 6 times 7 minus square root of 6. And that's really the hardest part, but once you see a pattern, there's actually a very quick pattern. I can say automatically this is going to be 49 minus 6. How can I do that? Well, let's take our time and then we'll see what happens. 7 times 7, and then 7 times square root of 6 becomes 49 minus 7 square root of 6. Do that again. 7 times 7 is 49, and 7 times the square root of 6 gives me a 7 on the outside, and a square root of 6 on the inside. Okay, let's do the backside. We're going to do square root of 6 times 7 and square root of 6 times square root of 6. That gives us square root of 6 times 7 is a positive 7 square root of 6, and a negative square root of square root of 6 times square root of 6 is 36. You could just have said 6 though, if you want to save some time. As we see in the middle, these terms will divide out. So we're left with, subtract out, so we're left with 49 minus square root of 36, which is 6, which is what we said back there, which gives us equals to 43. Now, just to practice this move real quick, we'll do it in just a moment, I'm sorry. Let's go ahead and finish up the problem. We're going to multiply the top. Negative 2 times 7 and negative 2 times square root of 6. That becomes a negative 14 plus 2 square root of 6 on top. And the bottom we said it was just going to be 43. Now let's plug that in again. 43. Oh, sorry. Negative 14 plus, I need to do a shift, that's my problem, plus 2 square root of 6, all divided by 43. Alright, super. Okay, so how does this problem get any more difficult? It really doesn't. As you can see in the next problem, same exact idea. The conjugate, instead of a plus, it would be a minus. This one, instead of a minus, it would be a plus. 4 over 4 minus square root of 14. The conjugate would be 4, not minus, plus square root of 14 over 4 plus square root of 14. And again, we're multiplying by the same thing because this is really just 1. We're just multiplying by 1. We're just making change. So let's do the bottom. So if you practice this enough, that's automatically going to be 16 minus 14. That's really just one move, but because the conjugates, the middle term cancels out. So let's go ahead and take our time real quick. 4 minus square root of 14 times 4 plus square root of 14. Now 4 times 4 is the 16 we were hoping for. 4 times square root of 14 gives us a positive 4 square root of 14. But on our next round, when we're doing the back, negative 4 square root of 14, these guys we're going to always cancel out. And 14 times 14, the square root of that becomes a negative 14. Because the square root of 14 times the square root of 14 is just 14. And positive times negative is negative. So we're left with that being 2 on the bottom. And multiplying the top, 4 times 4, 4 times 4 square root of 14 is 4 times 4 is 16. Plus 4 square root of 14. Okay, let's go ahead and plug that in again. 16 plus 4 radical 14. Oh, darn it. I should put that in a fraction. (16) plus 4 square root of 14 all divided by 2. Oh no. Oh, you have to reduce. I wasn't paying attention. I was rushing through this. Yeah, you have to reduce. Can I divide 16 by 2? Yes, that's 8. Can I divide 4 by 2? Yep, that's 2. And you can't touch the square root. Okay. Hopefully you found this helpful. There are some problems here where there's a square root on top. I'm just going to find one real quick. This one has 2 square roots. Let's do this one in case you might see this. So it will be 10 over negative square root of 3 plus square root of 15. And the conjugate here, same exact rule like we did before. We're going to multiply by square root of 13, also square root of 3, negative square root of 3, minus the square root of 15. We always change that middle value so we can be consistent here. So when I multiply the denominator, it looks like it'll be really messy, but I can tell you right now it's going to be 3 minus 15. Automatically I can tell you that. Let's take our time. Square root of 3 plus square root of 15 times negative square root of 3 minus square root of 15. Negative is a positive. Square root of 3 times square root of 3 is just 3. Our middle terms would have been positive, multiply to the back, positive square root of 45. Negative 15 times 3 is 45, so negative square root of 45. And square root of 15 is just 15, or negative 15. We said our middle terms are always going to cancel out. That's the great thing about conjugates. You can always guarantee that your middle terms are going to cancel out. And we're left with 3 minus 15, which gives us our negative 12. So in the back here, we're already down at the bottom. That's negative 12. On the top, we're going to multiply 10 by everyone on the numerator. 10 times square root of 3, 10 times 15. And this is going to give us our negative 10 square root of 3 and a negative 10 square root of 15. And now we have to reduce so that we can divide everyone by 2. So it will be negative 5 square root of 3 minus 5 square root of 15 all over negative 6. Let's get rid of the negative sign. we can divide everyone by a negative, equals to 5 square root of 3 plus 5 square root of 15 all over positive 6. Now let's go ahead and plug that in and see if we got that right. Fraction, we're going to say it's positive 5 radical 3 minus 5 radical 15 all over 6. Oh no. Oh my goodness. I wrote a minus when I should have wrote a plus. But I did write the correct answer here. I don't know why I wrote the negative sign. Okay. So I just inputted it wrong. Same frustrations that you guys have. Okay. I just gotta be more careful next time. Alright. Hopefully that was helpful. The iExcel assignment is posted today.